Okay, this video is going to review some Algebra 2 concepts that we're going to do in Pre-Cal also. We're going to talk about a reciprocal function and a reciprocal square function today. We're going to talk about transformations and putting them into graphing form. So the first thing we want to do is review our parent function, y equals 1 over x. The domain for this is all real numbers except right here. And x can never, ever, ever equal 0. So the way we write this is from negative infinity to 0 or 0 to infinity. Our range is every y value above 0 and every y value below 0. So it's the exact same as the domain. Because we've got asymptotes that fall on the x-axis and the y-axis, we do not have x or y intercepts. DNE represents does not exist. The horizontal asymptote, which I call hey, is y equals 0. And your vertical asymptote, which I call vax, is x equals 0. The end behavior for the reciprocal function, as x goes off to infinity, this way, this way, this way, this way, your y values are getting closer and closer to 0, but they're right above 0. So since they're above 0, we put a plus 0. And as x goes off to negative infinity, they also get closer and closer to 0, but they're below the x-axis. So we're going to say 0 and we're put a little negative up here, meaning it's right below it. The symmetry for this graph is with respect to the origin, which means I can double flip it. I can flip the right side over the y and then over the x, and it would land on top of itself, which we call the origin. It's not continuous because we have asymptotes in our graph. We're increasing from negative infinity to, we're not increasing at all, my fault. We're decreasing from negative infinity to 0, and then again from 0 to infinity. The second function we're going to look at, and again this is just a review from Algebra 2, is our reciprocal square function. The reciprocal square function also has asymptotes on the x and the y-axis. So your domain goes on forever and ever and ever, but again, we can never, ever, ever touch the 0. So negative infinity to 0, 0 to infinity. Your range values are only above the x-axis this time. So it's all your y values that are greater than 0, which we write from 0 to infinity. Again, we don't touch the x or the y-axis, so they do not exist. Our horizontal asymptote, or our hey, is y equals 0, and our vertical, or our vax, is x equals 0. So just the same as the reciprocal function. The end behavior, this time both pieces are above the x-axis. So as x goes off to positive infinity, we get closer and closer to 0, but we're above. As x goes off to negative infinity, we get closer and closer to 0, but we're still above. So this one has two plus signs above it. This is not symmetric to the origin. It's symmetric to the y-axis, which means it's an even function. This one is also not continuous because we have these asymptotes. The interval of decrease, the function is decreasing from 0 to positive infinity, but this one actually increases, and it's increasing from negative infinity to 0. So now what we're going to do is we're going to look at both these functions, and we're going to do some transformations. You're really good at transformations, so this shouldn't be too hard. So the first equation that we're looking at, if you have your hard copy of notes out, this one is the 1 over x function. So we're thinking about the one we just went over, 1 over x. And if you'll notice, in parentheses, it says we're going to go minus 2, but we know to do the opposite. So now I'm going to take my regular function and go right 2. Outside of the parentheses is a plus 3, which means I'm going to shift up 3. So I'm going to take this same graph that we had right here, and I'm going to move it right 2, and I'm going to move it up 3. So I usually move my asymptotes first. So I'm going to move my vertical asymptote to the right 2. So I'm going to just sketch it in right here, because it was right here at the axis, and now I moved it right 2. I'm going to move my horizontal asymptote up 3. So 1, 2, 3. I move it right here. Okay, and once you move your asymptotes, the rest of the graph is really easy. You're going to go out 1, up 1, and then you're going to draw a curve that approaches both the asymptotes. And you're going to go back to the little center, and you're going to go left 1, down 1. And you are also going to approach the asymptotes from both sides. So that's my transformation. So they want to know my horizontal and my vertical asymptotes. Again, I call them vax and hey to help me remember. So the y is touching at 3, so my horizontal asymptote is y equals 3. It's going through the x-axis at 2, so my vertical asymptote is x equals 2. The domain is going to be everything from the left and right except what x value? The x value of 2. So it's going to go from negative infinity to 2, and then from 2 to positive infinity. And my range is going to go up and down everywhere except in this y value right here. So it's going to go from negative infinity to 3 and from 3 to positive infinity. So your horizontal asymptote and your range kind of go together, and your vertical asymptote and your domain go together. You can see that both those numbers are in there. We can't be those numbers. All right, number 2 in our notes says y equals negative 1 over x squared minus 2. So this time we're using this function. So we're looking at this guy right here. And it's got a negative, so everything up here is going to flip over. And it has a minus 2 not in parentheses, so it's going to move down 2. So again, I like to move my asymptotes first. Since I'm just going to be going, we're going to reflect over the x. That's what this is going to do. And then we're going to go down 2. Since I'm going to go down 2, my horizontal asymptote that was at 0 is now going to be at negative 2. Normally, and this one stayed right here. We're not going left and right at all, so he's still here. And normally I go out 1, up 1, and I draw it, and I go left 1, up 1, and I draw it. So we're going to do the same thing, except this time I'm not going to go out 1, up 1, because it's going to reflect. I'm going to go out 1, down 1, and then I'm going to go the other direction, out 1, down 1. And it's going to kind of look like an upside down volcano. That's what I like to think about it like. And there we go. So now we can do our horizontal and our vertical asymptotes. Remember horizontal, I remember of hay, and it looks like I'm touching the y at 2, so y equals 2. My vertical asymptote didn't move at all, so back, x equals 0. Remember your domain and your vertical asymptote go together. So if you'll notice, my x's can be everything but right here, so they can be everything but 0. So they go from negative infinity to 0, and then 0 to infinity. My range can be everything but this y, and again, same numbers as your horizontal. So it goes from negative infinity to 2, and 2 up to negative infinity. Actually, these should be negative 2. That was a mistake on my part. Sorry about that. Okay, so that's the first 2. Number 3 in our notes is worded just a little bit differently. You probably haven't seen this. I don't know if you did this in Algebra 2 or not, so this might be the new piece. It says that they want you to let f of x equal the parent function 1 over x, and g of x is going to be 1 over x squared. So when we're doing this problem, we need to remember that this is my f of x function, and this is my g of x function. And they want me to focus on the f function, so I'm focusing on this one. And it says right here we're going to have an x plus 2 in parentheses, and then we're going to have a plus 1. So what you're going to do is you're going to take right here what's in parentheses, and you're going to put it in parentheses right there. So I'm going to go rewrite this as f of x equals 1 over, the 2 is in parentheses, so I'm going to keep it in parentheses, put it right there, and the 1 is not in parentheses, so it's going to come out like this. So now this looks familiar. They want me to describe the transformation. So because this is in the parentheses, it's going to do the opposite, so it's going to go left 2. This is out of the parentheses, so it's going to go up 1. And then what they want me to do is find my x and y intercepts. There's a couple ways to do this. You can do it by looking at a graph, or you can do it by plugging in. So I always like to see if my graph works first, so that's where I'm going to start. So it says plus 2, so I'm going to go left 2. So my original vertical asymptote is on the 0, but now I'm going to put it at negative 2. And my original my horizontal asymptote is at the y-axis, but now I'm going to go up 1. Okay, there's no reflecting, so what I remember from earlier is that from this middle point right here, I go out 1, up 1, and I'm going to approach both asymptotes. From this middle point here, I'm going to go left 1, down 1, and approach. So it looks like from my graph, I can tell that my x-intercept is going to be 1, 2, negative 3. So my x-intercept is x equals negative 3 or negative 3, comma 0. My y-intercept, I really can't tell for sure, so I'm going to have to solve for that one. I can tell that it's going to be bigger than 1, but that's really all I know. Okay, so to solve for your x and y-intercept, if you can't get it from the graph, what you have to remember is when you're doing a y-intercept, you're going to let x equals 0. So here's my equation right here. Y equals 1 over, and I let x equals 0, 0 plus 2 plus 1. So 0 plus 2 is 2, 1 over 2 is 1/2, plus 1 would equal 1 1/2, which makes sense because I said it was going to be above 1. So my y-intercept is 0, 1 1/2. Now let's just pretend that we couldn't find our x-intercept from our graph. We do the same kind of thing right here, except we would let y equal 0. So right here where I have y, I'd have 0 equals, and then I'd go back to my equation, 1 over x plus 2 plus 1. And then I would solve this equation like in Algebra 1. So we'd minus 1 from both sides first. The x plus 2 is in the bottom, so I would remember to multiply both sides by x plus 2. So if I multiply the left side by x plus 2, I'd have negative 1, x plus 2. If I multiply the right side by x plus 2, I just get a 1. I distribute that negative x, that negative 1, and I would get negative x minus 2 equals 1. I'd add 2 to both sides and get 3, and I divide by negative 1 and get negative 3, which is exactly what we got over here on our graph. So it's just confirming the fact that it did touch at negative 3. Okay, let's go look at number 4. So on number 4, it's the same kind of concept. They give me f of x is 1 over x and g of x is 1 over x squared. And they want me to figure out what g of x minus 3 plus 4 is. Well, the x minus 3 is in the parentheses, so it's going to go down here. So I'm going to go rewrite it. It says write the equation in terms of x. So y equals 1 over x minus 3. Because we're doing the g function, I have to put my square out here. And then the plus 4 is not in the parenthesis. So again, we can find our x and y intercepts by looking at the graph or just by plugging in. I'm going to start by looking at the graph like I did last time. It says x minus 3, so I'm going to go right 3, 1, 2, 3. We do the opposite. Okay. It says plus 4, so I'm going to go up 4. Okay. This is an x squared function, so for x squared, we go right 1, up 1, and it's on the positive side. And then I go back to my little middle spot, and I go left 1, up 1, and I approach both spots. So one thing I can tell by looking at my picture is that I'm never going to touch the x-intercept. So the x-intercept does not exist. So I'm never touched down here. But I am touching the y. So because I'm touching the y-axis, I am going to have to solve for a y-intercept. So let's remember how to do that again. To do a y-intercept, we're going to let x equal 0. So I'm right here, and I'm going to let this x be 0. So y equals 1 over 0 minus 3 squared plus 4. All right. Well, 0 minus 3 is negative 3, and negative 3 squared is 9. So I have y equals 1/9 plus 4, or y equals 4 1/9. So my y-intercept is y equals 4 1/9. Well, let's see if that makes sense. 1, 2, 3, 4, and I'm right above it. Yeah, that makes sense. So it's 0, 4 1/9. And again, I don't have to go find my x-intercept because I know by looking at my picture that it doesn't exist. All right, so now we're going to work backwards. I'm going to give you a graph, and you're going to try to tell me what the equation is in terms of x and g of x. So we're still going to go back with my f of x is the reciprocal function, and my g of x is the reciprocal square function. So by looking at this picture, I can already tell that this is a, I'm looking at the wrong problem, sorry. By looking at this picture, I can already tell that this is an f of x equation. So this is a 1 over x. And remember, when we're doing 1 over x, my original asymptote is right here on the y, but it looks like it moved. And let's see if we can figure out what it moved to. It looks like I'm using -2, -3. I'm getting really close to the -4, but we're never using it. So it looks like I went left 4, but it doesn't look like I went up or down at all. So I only went left 4. So if we went left 4, we'd have y equals, because we went left, I would do the opposite, and I'd write x plus 4. Because I didn't move up or down at all, I don't have to put anything out here. Then they want me to write it in terms of f of x. So when we write it in terms of f of x, we just write f of whatever's in parentheses. I keep in parentheses. Because we didn't add or subtract anything, I don't have to put anything out there. That part's done. So then they want me to go back and review my horizontal and vertical asymptotes. So again, I like to remember Vax and Hay. So I touch the y at, well, the asymptote touches the y at 0. The vertical asymptote touches the x at -4. And then I remember that my domain and my Vax go together. So it's going to go from -infinity to -4, and from -4 to infinity. My range and my Hay go together. It's going to go from -infinity to 0, and from 0 to positive infinity. All right. On number 6, we can tell this is the volcano one, and it happens to be the one that's upside down. So the volcano one is the one that looks like this. At least that's what I call it, the volcano. Because it's upside down, I know it's a reflection. So y equals -1 over. It looks like I moved this direction. So I went 1, 2. Looks like I went right 3. So if I went right 3, I have to do the opposite. And remember to put my square. It doesn't look like I went up or down at all, so I don't need to add anything. Okay, so there's my equation in terms of x. Now they want me to do it in terms of g of x. When you do the g of x, there's a negative out front, so I write a negative. I do the g. Whatever's in parentheses goes next. I don't need the square. This tells me to do the square. I'm not adding or subtracting anything, so that's it. We're going to review the horizontal and vertical asymptotes one more time. So again, we've got Vax and Hay. My asymptote is touching the x-axis at +3. My asymptote is touching the y-axis at 0, so y equals 0. The domain and Vax go together, so it goes from -infinity to 3, and from 3 to infinity. The horizontal asymptote and the range go together, so it goes from -infinity to -infinity to 0, but everything's down, so it's going to stay right there. It says nothing is above the 0. It's not like the reciprocal where one's up and one's down. Okay. All right, so now that we've talked about transformations, we're going to look at what do we do if it's not in graphing form. So now what we're going to do is we're going to focus on putting some equations in graphing form. So the first step to putting things in graphing form is, if you can, to factor. So that's what I'm going to start with. So x squared minus 6x plus 9. I know I can factor that to be 1 over x minus 3 times x minus 3, which I know I can rewrite as 1 over x minus 3 squared. So now, if I asked you to graph this, you would know that it's a reciprocal square function, and it's moving to the right 3. So 1, 2, 3, dot, 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 dot. It didn't move up or down at all, dot, 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 dot. It's a reciprocal square, and it's not a reflection. So it would look something like the volcano. So that's not so bad. On number 8, again, we're going to go try to factor first. So the top just stays like it is. On the bottom, I can pull out a GCF of 3, and I get x squared plus 4x plus 4. This can factor again, and I get -3 over 3. X squared plus 4x plus 4 is x plus 2 squared. These can reduce or simplify out. So I have y equals -1 over x plus 2 squared. Again, this is a reciprocal square function. This time we're going to go left 2, and I'm going to reflect. So when I graph this one, I'm going to go left 2. I'm not moving up or down at all. Normally, if I was going to do the volcano, I go right 1, up 1, and draw, and then I go left 1, up 1, and draw. Because it's a negative, I'm going to go right 1, down 1, and it's going to go like this, an upside down volcano, and then I'm going to go left 1, down 1. Okay, and there's a picture. All right, on number 9 and 10, there is no factoring to do. On this one, what we're going to do is we're going to review division. So we're going to be dividing these long division so that we can put it in a graphing form. So when you can't factor, we're going to see if long division works. So the x plus 5 goes on the outside of the house. The x plus 6 goes on the inside. And we're going to start with the first term. How many times will x go into x? It'll go 1 time. And then we're going to remember we have to multiply 1 times x plus 6. X plus 5, and we get x plus 5. And then our rules of long division are to subtract these. X minus x is nothing. 6 minus 5 is 1. So it's remainder 1. So what we have to remember back from, I don't know, I think it's 2nd or 3rd grade, is your remainder goes over what you divided by. So this answer is going to be 1 over x plus 5, the remainder over x plus 5, and then I've got this plus 1 on top. So the equation that we have is 1 over x plus 5 plus 1. So if I were to graph this, it would be a reciprocal function. It's going to go left 5 and up 1. So I'd go left 5, 1, 2, 3, 4, 5, and I'd go up 1. Those are my asymptotes. Okay, this is the reciprocal function, so this is not the one that looks like the volcano. So I go to my middle point, and I go out 1, up 1, and I draw the top half up, the right half up, and then I go back to my center, and I go left 1, down 1, and I draw the left side going down. So it looks something like that. Okay. Number 10, same thing. We're going to review long division again. So I'm going to take this x minus 2 and divide it into x minus 3. How many times will x go into x? 1 time. And then I'm going to say 1 times x minus 2 is x minus 2. We're going to subtract them. X minus x is nothing. -3 minus a -2 is the same as -3 plus 2, which is -1. Okay, remember, the remainder goes on top of what you divided by. So y equals, my remainder is -1 over, I divided by x minus 2, and then I'm going to add whatever we had on top, plus 1. So this is the reciprocal function again. This time I'm going to go right 2, up 1, and I'm going to reflect. So I'm going to go right 2, there's my first asymptote, and I go up 1, that's my second asymptote. Here's my middle point. Now normally I'd go right 1, up 1, and I draw it, but because I have a negative, I'm going to go right 1, down 1, and this time the right side's going to go down. Normally I'd go left 1, down 1, but this time because of the reflection, I'm going to go down 1, up 1. And there's your graph. Okay. 11. On 11, on this one, they try to do a little bit tricky here. You just have to know how to rewrite this. So what we're going to do is we're going to rewrite this one fraction as 2 different fractions, and hopefully you'll notice what happens. So I've got 1 minus x plus 3 squared over x plus 3 squared. So we're going to go write one fraction as 2. So 1 over x plus 3 squared minus x plus 3 squared over x plus 3 squared. So I took this first number and put it over x plus 3 squared, and then I took the second term and put it over x plus 3 squared. Well, anything divided by itself is 1. So we have y equals 1 over x plus 3 squared minus, and again, anything divided by itself is 1. So here's my equation. So I know it's a reciprocal square function. It's going to go left 3 and down 1. So I'm going to go left 3, 1, 2, 3, dot, 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 down 1, dot, 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 dot. Okay, this is a reciprocal square function, so these are my volcanoes. So when I do a volcano, I go back to the middle, go right 1, up 1, and then I approach, and I go left 1, up 1, and I approach, left 1, up 1. So these are the ones that look like the volcanoes. Number 12 is very similar, except that the bottom can be factored. So we have 1 over x minus 2 squared. The bottom can be factored into x minus 2 times x minus 2, which I could rewrite as 1 minus x minus 2 squared over x minus 2 squared. Now this looks a lot like the original problem I had over here. So I'm going to write this one fraction into two different ones. So I'm going to have 1 over x minus 2 squared minus x minus 2 squared over x minus 2 squared. So we have y equals 1 over x minus 2 squared minus anything divided by itself is 1. So this is going to be the reciprocal square, my volcano. It's going to go right 2 and down 1. So that graph might look like this. We're going to go right 2, 1, 2, dot, 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 down 1, dot, 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 dot. So here's my middle. Again, it's not a negative, so my rule is to go out 1, up 1, and approach both asymptotes. And then I'm going to go left 1, up 1, and approach both asymptotes. It's the volcano. Okay, almost done. On 13, what we're trying to do is we're trying to solve for y. We're trying to get y by itself. Don't know why there's a second y out here like this. That's the equation. So one thing to do would be to take the 4 and divide it by x, or we could go and distribute. I'm just going to say that y plus 1 equals 4 over x. And then I have to move the 1 over, so y equals 4 over x minus 1. So this one is a reciprocal function, right arm up, left arm down, but it's got a stretch of 4 and it shifts down 1. So it doesn't go left or right at all. So this asymptote is still right here. It does go down 1. Okay, so here's my center right here. Normally with a reciprocal function, I go out 1, up 1. If it has a stretch of 4, I'm going to go out 1, up 4. So 1, 2, 3, 4. That would be my first one. And then it approaches really quickly. You're going to do the same thing down here. I normally go left 1, down 1. I'm going to go left 1, down 4. 4. So it just approaches like really steep and fast. Okay. And the last one is going to be the same type of problem. I have xy minus y equals 1. So we're going to try to make it look a little like this one over here that we just did. I'm going to factor out my y, and I get x minus 1 equals 1. And then I'm going to solve for y. So y equals 1 over x minus 1. So now I can see that it's a reciprocal function. It's a reciprocal function, which means the right side up, left side's down, and it went right 1. So I go right 1. It didn't go up or down at all, so it stays there at the 0. There's no stretch, there's no reflection. So I'm going to go right 1, up 1, and then I'm going to approach both asymptotes. I'm going to go left 1, down 1, and I'm going to approach both asymptotes. Okay, so we did a lot of review today. You're going to actually have 2 worksheets that are going to be due this Friday. So you have till Friday to get them to me. This first worksheet called Transformations of Rational Functions. I'm not going to take any out. They're all pretty easy. I did some of these same problems in your notes, but let's just make sure you get it. So on number 1, they show you this picture and they want the equation. So we know this is a reciprocal equation, and it looks like it shifted. 1, 2 to the left, but it didn't shift up or down at all. So hopefully that will help you. On number 2, I can see this is a reciprocal square function. So this is the one that's got the x squared. It didn't go left or right at all, but it did go up and it reflected. Okay, so we're going to do everything on this worksheet front and back. On the second worksheet where it says graphing form of rational numbers, I did some of these exact problems in the video, so as you're doing these, look at the video. I think I did like every other one of them with you. All you have to do for each one of these problems is go write it in the graphing form. So write the equation right over here. After you write it in the correct form, you're going to come over here and graph it. And then you're going to write down your horizontal and vertical asymptotes. Notice I got rid of the x and y intercepts here. And you're going to do your domain and your range. You're going to do the exact same thing for number 2. However, big change. On number 3, I want you to go find your x and y intercepts. So on number 3, you're going to find the x and the y intercepts. You're going to find the x and the y intercepts. Okay? So flip it over to the back. I did one just like number 4 with you in your notes, so please go back and look. You're going to put it in graphing form, write the equation for me. You do not have to find your x and y intercepts on number 4. I do want you to find your x and y intercepts on number 5. And I do want you to find your x and y intercepts on number 6. So let's recap. You're going to not do x and y intercepts on number 1 and 2. You will do it on 3. You're going to not do the x and y intercepts on number 4, but you will do it on number 5 and on number 6. So 3 times you're going to do it, and 3 times you're not going to. Okay, I hope this video helps. If you need more help, please come see me in tutoring.